Hello to everybody. Today we are going to see. Now we will see the various stages of the combustion process in the SI engine with respect to pressure and crank angle diagram. With respect to pressure and crank angle diagrams. So here the combustion process we are there are three stages. One is the ignition lag stage. Second one is the flame propagation stage, and the third one is the afterburning stages. Okay. Now let us see here the P theta diagrams. Okay. So here at the point of A, the compression is taking place. So the compression pressure is increasing. Slowly it is increasing in the during the compression stroke. Okay. So before reaching the TDC at the point of ignition, the point of A, the ignition or the spark plug is giving spark. Okay. Now this spark is maybe a nanosecond is required to caught the fire in the fuel and air fuel mixtures. So up to the point B, the the spark is traveling and reaching the air and fuel mixtures. So now at the point of B, the air and fuel mixtures got fired and the combustion is starting at the point of B. So there from there it start traveling, the flame front is traveling and reaches the maximum pressure at the point of C. Now the maximum pressure is reaching after the power stroke 5 to 10 crank angle, it is reaches the maximum power. After attaining this maximum pressure, further the combustion process will be continuing, but due to the expansions, the pressure is decreasing. Further up to the point D, the further that pressure will be decreasing and the combustion process will be end here, and further it is expanding. Okay, so this is the normal process of a combustion stroke. Now we will see what is a ignition lag stage. So ignition lag stage is the time interval between the instant bath and instant where there is noticeable rise in pressure due to the combustions. So this time is called the ignition lag. This process, the time travel is during which the molecules get heated up to self-ignition temperature and get ignited and produce the self-propagating nucleus. So ignition lag is very large and small, lies between the 0.0015 to 0.0012 seconds. An ignition lag of 0.00 seconds corresponding to 35 degrees of rotation when the engine is running at 3000 rpm. Now let us see the ignition lag. Okay, so see here, this is the ignition number one. Ignition number one is the where which the exactly the spark plug is giving ignitions. Thereby see the smooth curve of the that will reaches the maximum power, and then it is further it is traveling, it is expanding, and the pressure is reducing once it is advancing the crank angle. So in the case of ignition lag, it is necessary to ignite the charge in the cylinder some degree before the crankshaft reaches the TDC. The number of degree advance before TDC at which ignition occurs is called the ignition advance. The optimum angle of the advance allow the combustion chambers to cheese just before the after the TDC, so that the maximum pressure is built up. Here the maximum buildable pressure is built up, and further the expansion stroke. This shows that normal indication of the smooth running operation. So the number one curve is a smooth curve, and the operations, the engine operation will be very smooth. Now if it is over advanced, so before the ignition number 2 means if the spark plug is going further over advanced, means during the compression stroke, the TDC, the piston reaches the TDC, that time period will be 2 further increases, that is called the over advance. So if the combustion is initiated too early, now see the curve of 2, so further the it may have a time period, so it may travel to highest pressures, thereby it may be pulsating during the expansion strokes, and thereby it may create a knock or other disadvantages to the engine. The engine running condition may not be a smooth enough. Okay, so that is called the over advance. Suppose if the uh, if the ignition is taking place under advance or retarded ignitions, suppose this is the curve of ignition 3. So at this point, if the spark plug is giving ignition, okay, now the curves, see, it may have a smooth curve, but the combustion process will be at the end of the power stroke, so it may not be possible to give the full power, so that it will be further, it is nullifying its combustion process. So that when the engine ignition retarded, the combustion is initiated late. In fact, the combustion will continue while the piston is sweeping out the power stroke. So maximum pressure will occur late and will not as high as that of the normal case. A retarded engine will less power, and due to that less burning engine, and efficiency will also decreases. Now let us see the second stage. So after ignition lag, so from the point A to B is called the ignition lag, and then the flame propagation. Now the combustion process, okay, it's starting at this point, point B. Okay, further the flame front will travels with the high, the steep rise in the pressure ratio. Now, once the flame is formed at the V, it should self-sustain and must be able to propagate through the mixture. So here it reaches the self-ignition temperature, and it can further travel without any spark or anything. So here the your pressure also rising very steeply, the temperature also. This is possible when the rate of heat generation by the burning is greater than the heat lost by the flame to the surrounding. After the point B, the flame propagation is abnormally low at the beginning, as a heat loss is more, and then heat is generated. Therefore, the pressure is also slow as mass of mixture is more. So therefore, it may be necessary at advance of 30 to 35 degree if the peak pressure reaches before after the TDC. This time is through an angle of Q2 is known as the flame propagations. Now next stage is after burning. Once it reaches the highest power, then the expansion is taking place. So it may be 10 to 15 degree after the TDC. After the TDC, so the combustion will not stop at the point of C, but continue after attaining the peak pressure, and this combustion is known as after burning. This generally happens when the engine rich mixture is supplied to the engine.